Alrighty, it's time for some super duper electron highways with Beans Brother. Now, I'll start out with an introduction with a description of lab and fundamentals. Let's go into our different labs and result in some final questions. And hey, this time we don't have any boring glow script to review, so that's cool. So for the introduction, let's first understand what we're doing. We're just looking at series and parallel circuits along with discharging. So some principles to help us cover that would be Ohm's law, loop rule, node rule, voltage of capacitors, capacitance, and rise time. Now for field calculations, we say that from the node rule that In is equal to I out, which is 0.02 amps from our case. We determine that because this entire circuit is in series, so we just simply say V total divided by V, our resistance total, will give us 0.02 amps. Now, when we plug in our ammeter backwards or forwards, it'll be the same sign. And if we have our voltage of 3 volts, because we have 2 batteries which contribute our 3 volts, then we could also say that from loop rule, we say that the summation of voltage is equal to 0. The reason why we make the distinction here is because now that you have your 3 volts total, you could double check your results once you find the voltage from 47 and 100 ohms resistors. These values are found by taking the idea that V is equal to IR and rearranging, you should be able to find volt. And the summation of these two voltages from the resistors should be equal to 3 volts. Now, RRC values are given on this plot, where you could see the 2 batteries. They increase volts, because that's kind of what a battery does, yes. Now, once we hit our first resistor and second resistor, you can see that our voltage drops. That's because of Ohm's rule, where V is equal to IR, and since current is the same, you could say that if a resistance increases, then your voltage would decrease. And of course at the end we get 0 because of the loop rule, where we see that the total summation of voltage is 0 at the end. So for lab A, we have some questions. When you attach a voltmeter, you alter the circuit. Why doesn't the ammeter, read a change pretty much? Now, a voltmeter has high resistance, so current takes the path of least resistance through the 100 ohm resistor. That's one explanation. But another one is that because of the node rule, when you have current that comes in and out, well, you could kind of black box the parallel circuit as its own individual electric piece, and since everything else is in series, things in series have the same current that flows through them all. Now, I want you to replace the voltmeter with an ammeter in parallel with the 100 ohm resistor. What happens to the current through the other ammeter and why? The ammeter will read an increase in amps because an ammeter has virtually no resistance in this case. The branch with less resistance will have more current flow than the one with higher resistance. This is due to Ohm's law, V is equal to IR, and special properties of a parallel circuit. Lab B. You have a bulb that's connected in series in RC, the bulb will be bright, but then it dims. And the same story is true for the discharging capacitor, where it will be bright and then dim. Time to discharge is from 10 ohms, 9.4 seconds, and 20 ohms, 18.1 seconds. Potential difference is given on this graph, and when you normalize it with the log natural, you get this pretty graph. The graph slope is negative 0.167. And RC is just negative 1 divided by that slope, which is approximately 6. Now, from the idea that RC is literally resistance and capacitance, if you multiply the resistance of 30 ohms by 0.2 farads, then you get 6, which implies that our model is, indeed, muy bueno. Now, final questions. What if you were to do this in real life and you have an actual ammeter instead of an ideal one, basically one with resistance? Well, real ammeters have resistance, since V is equal to IR, and the current is the same across all electrical components in this series. The extra resistance would lower the voltage of the latter electrical components underneath that in the circuit. What if you were to do this lab in real life? You have resistance. What would you expect for the capacitor? Well, it has zero resistance, so it would start pretty much immediately at the peak. And in real life, even though it would start really, really fast and climb towards that peak really, really fast, the resistance is still present. It'll take a bit of time to peak and then discharge. Anyways, guys, that's all. I'll be going out to eat dinner, and after that, go to sleep. And I hope that you do something similar. Anyways, have a healthy and safe night. See you guys.